Hey guys, what's up? Eddie Alho here with KissAnalog.com. Today what we're going to do is do a Bode plot of these two Class D amplifiers, okay? This is a 200 watt by 200 watt amp in 8 ohms. This is 150 watt by 150 watt 8 ohms, okay? Pretty similar. This one's a discrete design, a bunch of op amps, transistors and that. This one has a microcontroller on it, alright? And I think there's a difference in the way they operate. Okay, so here's the thing, is I've done reviews of both these. I have a playlist I'll put down below. Okay, I've done some other Class D amps and some other amplifiers in this playlist. Well, alright, so this guy was a little bit wonky. I don't know how else to describe it. It was kind of crazy actually, okay? So what we're going to do is I want to see if we can get some confidence in doing Bode plots, because I had a lot of comments and there's some interesting ideas, and one was kind of a concern. You know, we have a digital scope doing testing basically digital amplifiers, and you know, was there some kind of timing or sampling issue or something like that? And I don't know. Well, so I want to do this test, and I'll tell you what I've done before I, trying to prepare for this is I looked into this in between, and I've put different, okay, first of all, let me tell you this. They both have preamplifiers. They both have pots on them. I think this is an analog pot, and this one over here is a digital pot because it's got a microcontroller. So, why not? But, so they have preamps. I can put a small signal in or a larger signal and compensate with the pots on how much amplitude I put out to the load. And I've got these 8 ohm and 4 ohm 200 watt resistors, okay? Well, I've done that, and I've done different scenarios. The scope has different sampling rates. I've tried different things. I get the same results. I can do a manual thing where I put a signal in, and anyway, I get the same results all the time. So I really think it is what it is. There's something really kind of interesting going on here with this guy over here. Okay, these are both evaluation cards, so they're really not meant to be production ready. You know, go out and buy and put it in your house or whatever. But they're meant to show off the GaN FETs in them. Okay, this one's efficient power conversion, and they make their GaN FETs, and I'll show you a close-up of them. What you don't see is heatsink. There's not very many big parts on this. I mean, there's a bunch of big old connectors, but same here. Bunch of big inductors on both of them. So this guy here is GaN Systems, okay? And GaN Systems makes their FETs, their GaN FETs. So that's the, the idea of this is to show off the GaN FETs, how well they work, all right? So, no heat sinks, pretty cool, literally. Pretty neat. Now, okay, let me just show you something, another Class D amp. This is a Class D amp, 200 watts per side. Pretty cool amp. I got this on Parts Express, and it was kind of a sellout. They're kind of, closing out this series. Too bad. I'd like to buy some more of them actually. But this one does have a big heat sink on it. Well, it's not that big for 200 watt by 200 watt amplifier, right? But yeah, pretty impressive. No heat sinks required on the GaN. That's pretty neat. So, pretty cool. Oh my. So, I don't know. When I did the gain phase on this, I got pretty much expected results. The only one that's not quite working out is this one that was from the GaN Systems. But the FETs themselves, very cool, very neat, like them. Alright guys, so what the test is going to be is, now just to let you know, in case you're not familiar with Bode plots, is, you put an input signal in, you have an output, okay? If you put 1 volt in, you get 10 volts out. That's output divided by input, 10 to 1, you get a gain of 10, alright? And then the phase, if you put it in, are you changing your phase of your signal, or is the signal coming through clean and same phase? So during the frequencies of interest for an audio amplifier, we don't really want a phase change. We want, if we put, when the sine wave goes up here, the output we want it to go up too. Okay, we don't want the phase to change so when it goes up that it's going down. That'd be a 180-degree phase shift. We don't want that. So that's what the gain phase plot tells us. And what I'm going to do is I'm going to use this 8 ohm load. It's a 200 watt resistor, pretty much non-inductive. So I'm going to try that. Then after I do that, then I'm going to take the speaker behind me and plug it in as well in parallel to this guy. And what it'll do is it'll just be another data point, because instead of having just a bunch of 8 ohm tests, it'll be 4 ohm tests, because it'll be 8 ohms for this, 8 ohms from that, so it'll be a 4 ohm test. And the amplifier will have to put out a little bit more, well, it'll have to put out double the power, because it's going to be powering this 8 ohms plus that 8 ohms, so 4 ohms. Same voltage, I'll use the same 8 volts out, okay? And then we'll see if that changes things. Let's come over here, I'm going to show you the setup, and we're going to look at the scope and watch signals. Alright, let's do it. Hey, by the way, before we jump over here and do this, give a thumbs up to the video if you like this. That helps YouTube analytics a lot, so go ahead and hit that for me. Thanks, appreciate it. And I want to thank the Patreons, everybody for watching the videos. And okay, let's come over to the bench. Oh, and by the way, one more thing. A buddy of mine went to Finland, and my ancestors are from Finland. That's why the Finland shirt. So, thought that'd be kind of cool. Alright, let's come over to the bench and do this video. Alright, so let's just go over the setup real quick. This is the EPC, efficient power conversion. We'll start with this guy. And you see these 3 colors here, the red, black, and the green? That comes in here from the power supply, okay? Up over there, the plus minus supply. So the plus comes in to this terminal, the minus comes in this terminal, and the return is in the center, the green. Okay? Then, so our FETs are down here, the big old LC filters are here, and there's some poly caps down in here too, the little white guys down there. Okay, that's a little bit closer look at the board, and you can see the FETs along here. I'll try to zoom in on the FETs here. These are the big LC filters. You can see a little closer, but let me zoom in on those FETs. Okay, guys, and you can see the GaN FETs right down there. Those little blue, teeny little blue guys down there. 2 more blue ones right there. See them? And 2 more right here, and 2 more in this shadow right there. It's very small. Then here's our pot that I can set the gain with. We have XLR inputs plus RCA, and we're going to come in this RCA input here, and we'll come on this output here. So just run through the 1 channel. Alright, so the signal here comes from the generator, and that's how the scope can track it and sweep it for the Bode plot. Then this is a ×10 probe that we'll be looking at the input. That's going in channel 2. And then this guy here is a differential probe. That's looking at the output, and that'll be going in channel 1. And that's through a Pintec DP. It's this guy right here. Okay, DP25. So that's our Pintec. Okay, and our load is this 8 ohm 200 watt. Pretty much non-inductive, and that's white wires coming in here. And then we'll use the amp probe here to look at the RMS measurement, so I can set that to about 8 volts. And we'll use this astrometer over here to look at basically right here, right across. So we'll see if I got plus minus 30, I should see 60 volts here. Okay, that way I can kind of monitor both voltages at the same time and do it with just 2 meters. Alright, so you know what? What I'm going to do is I'm going to power it up just so you can watch the LEDs and all that kind of stuff light up and watch the meters, and we'll see where we are. I got the generator turned on and it's set to the right voltage, so let's just bring the supply up. So you'll see it come here. You'll see some red lights here. Watch this. When I start to apply enough voltage where, okay, first this blue light comes on, and then you got a couple red lights saying the voltage isn't high enough. And you'll see over here, so that's plus minus 15. So right about plus minus 20 is where the red lights turn off. And then there's some green lights up here, if you can see those. Okay, and then I'll bring the voltage up, and right here you see we're set just a little bit above 8. Let's crank that down a little bit. Right about, well, it's going to be just above 8, okay? We'll try to get both amps about the same. Okay, I'm going to turn off the power supply and talk to you a little bit more. It's kind of noisy with the power supply running. Alright, so let me just show you. Oh, and by the way, these leads right here are for the speaker. And I'll just plug those in to, well, right here to the output when we do the speaker test, okay? Okay, here, let me just show you the supply up here. Alright, and we'll be using this GW Instack power supply. So we got them in series mode. I've got one switch on volts, so I can watch voltage here, one switch on current, watch current here. And so I'll be watching for 30 volts here, meaning I'll have 30 volts there, and I can watch the current, see if anything crazy happens. So they're in series, so this is the master. I'll be controlling it here with plus and minus. Well, this is return, so this will be the plus 30, and this will be the minus 30. Okay, internally these tracking generators are tied together. Alright, so channel 1 is the output, the differential probe. Okay, and so in the setup for the Bode plot, we got output channel 1, input channel 2, and that's the scope probe times 10. Alright, so it's kind of close up here. On the setup, I come to here, and I have output for channel 1, that's the diff probe, and input channel 2, that's the scope probe. So it'll be output divided by input. Okay, and then generator setup, it'll be 20 hertz at 200 kilohertz, 1.2 volts with the high Z. So that should work. We should be ready to go. I just had to hit run, but I got to bring up the power supply first. So let me do that, and I'll zoom in just a little bit more. Okay, guys, I'm going to turn on the power supply. You'll hear the fan turn on. Bring up that voltage here. Okay, there's 30 volts. Okay, we're going to go ahead and hit the run. And you'll see the yellow one, the output, and the blue one. And they look like they're pretty close to in phase. It's just starting. Now, because the input filter, they'll be slightly out of phase, and that's to be expected. Now they're right on top of each other. That looks great. But as the scope auto adjusts the scale, so it kind of does it in steps. So sometimes they look like they come out, but that's just the scope stepping through. So the gain is on the left, the blue, and that's 25 dBs right there. And these auto adjust to the gain and the phase. So the red's the phase. Okay, look at that. That's 10K, and that's 20. Look how flat the gain is. See, it's auto adjusting the scale. That's why it's pushing it up. Okay, it's done. 200K. Alright, I'll turn down the power supply, so get rid of that noise. And look at that. The gain is very flat. It's like right on the line, and then out to 20K, and then it has a resonant peak because it really drops off fast. See, it goes from about 200K at between 5 and 6 dBs, pretty close to 6 dB, and it crosses 100K at about 15 dB. So it's almost that's pretty close to 10 dB per octave. That's pretty steep curve, and that's why it has a resonant peak. Now this is into an 8 ohm load, and you can see the phase is really flat out to 10K, and then you know, really drops off. So there's 180, and then it starts to redraw up here, but really you could imagine that just continuing on down here. Alright, so I thought this was kind of interesting how, you know, they didn't dampen this very much, but I put a speaker load on this, and with the speaker load, we'll look at that. Okay, it actually looks really good. Alright, so now we're going to hook up the GaN systems board and test that one. So 8 ohm load tied to this channel output. Also, the multimeter right here tied to that, so I can set it for 8 volts. And then the diff probes are tied there too. Okay. Then this is the power connector, and I've got the red, green, and black tied to the appropriate wires. It wraps around here, and lab power supply. And this multimeter here is plugged in the same place as was on the previous test. So generator from the scope right here, and channel 2, looking at the input right there. So yeah, diff probes on channel 1. Okay, everything else is the same. Let's go ahead and plot this. Alright guys, this is a pretty close-up view. You see the large inductors, all the big, the LC filter out here with the poly caps as well. And the FETs themselves, these 2 black guys right here, there's 2 more. You see there's the bridged outputs here, the other bridged outputs here. Pretty darn small, aren't they? And here's processor. I'll zoom in on that. And there's the brains of the operation, I guess. And then over here you see the low voltage regulator outputs. And here's our selector switches up here. That's for the open and closed loop. And this is a reset actually for the peripheral. And well, this is peripheral and this is for the microchip. And then our toggle switch for the different inputs, because you can see there's optical, there's a coax, and there's RCA, and then there's a little 3.5mm down here in the corner. So yeah, a lot of stuff going on. Okay. Alright, so let's go ahead and run this thing. Okay, here we go. Whoop, I gotta turn on the power supply, of course, sorry. Okay, you'll hear the fan turn on. Okay, let's bring power up. About 30 volts on the output, I think. 30 volts on the power rails, plus minus 30 volts. Just the way I did the last amp. Okay, I think we're getting ready to scan. It's getting all ready. Okay, let's go. FR run. FRA run. So gain on the blue side, it'll auto scale. Phase on the red side, that'll auto scale as well. So you can see already the phase is just taken off, and you can see it visually up here. Now when it kind of jumps, that's when the scope is auto scaling the horizontal, and it's also keeping the vertical inside that window. So it auto scales the vertical and the horizontal if need be. Okay, so I've tried different amplitudes, input and output. I've tried different things, and I keep getting the same waveform. I can also sample this thing slower. It takes a lot longer to run across, but I still get the same wave shape. And this sample rate's fairly, it's not super fast. There's a couple faster settings, but yeah, I get the identical waveform out as far as phase. The gain line would shift depending on my gain. But yeah, see the gain, and then that digital filter, just wow, that drops it like a whole bunch of dBs in no time at all. Okay, we're done. I'm going to freeze the scope and turn down the power supply so we can talk without that noise. Alright guys, so you can see this thing is very flat in the gain, and then it just boom, it just takes it falls like a brick. But that phase is just insane. So when I did this in the last video, you know, raised a lot of questions, so that's why I'm doing this video. Okay guys, what I'm going to do, I'm going to plug in a speaker in parallel to the resistor. Okay, so 8 ohm speaker here. Now you'll hear it, and I'll turn down the volume in the video probably because it's going to be loud. Okay, so I'm going to do about the same wattage, and here, let's get the scope going again. I'll get the power supply back up. Okay, here we go. Get 30 plus minus 30 volts again. Okay guys, let's run it. Whoa, that's gonna be loud. You can hear when the oscillator takes these steps in frequency. Wow. Whew. Okay. Yeah, that's probably not real great for my speaker. It's a Paradigm. It's a pretty nice speaker. It's meant for a center channel. It's pretty nice, but it's probably not good for it. So that digital filter out here, we shouldn't have heard anything because there shouldn't be any gain. But you did hear pops because what I noticed is filter, and you can even see the phase reacting. What happens is, I think the filter is sampling, and if you change the frequency quickly, or maybe even the amplitude, I notice it takes a moment to, to see that and to turn off the amplitude. Meanwhile, you get a little blast out. So that's what that chirping was, I think. But yeah, you notice this still looks the same, even with the speaker connected. And yeah, pretty crazy, right? Alright guys, that was very loud, so I was going to have to edit that out anyway. So I just showing you the result. So this is the other amplifier, the EPC, that had that flatness and then a resonant period and then it shut down. Phase still looks the same, but now look what's happened to that resonant. Instead of having a gain in amplitude, it kind of drops and it just comes up a little bit, drops. So with an actual speaker driver load, an inductive load I suppose, it made the difference out here on this resonant hump. So that's pretty interesting. Out to 20 kilohertz, it looks pretty darn good in both the phase and the gain. Hey guys, so what do you think of that? Pretty interesting stuff, right? So I just wanted to show that this setup seems to work really well with one type of Class D, and I've done other Class Ds in the past, and I plan on doing some more, and I just wanted some confidence in this setup. This is the only guy that's some wonky kind of results. But again, these aren't production ready boards. They're meant to evaluate the GaN FETs and show off how cool they are because no heat sinks. That's pretty neat. This guy, he's about the same wattage, I think around 200 watts side, Class D, but not GaN FET, MOSFET, and it has this heatsink. Not a huge heatsink, not for this kind of power, not bad at all. I mean, this is not bad at all. So, not compared to this Class A amp over here. Hey guys, if you like this video, a thumbs up really helps the channel, YouTube analytics, all that kind of stuff. I appreciate all your comments, and thanks to the Patreons for all the support. That's great, that's awesome. And you can become a patron for as little as $1 a month, by the way. But yeah, I'm buying I bought one box. I'm still kind of shopping for a box for this. They're kind of expensive, because they have to be big heat sink. So yeah, kind of expensive. I got some Class A, B, some other Class D amps, and so I want to review them, and I just wanted to make sure we all felt pretty comfortable with how this worked and that it actually does work with a Class D amp. And something's just a little bit wonky with that one. Alright guys, hey, thanks for watching, and give me a thumbs up if you like it. We'll see you next time.